Experiment number 5, verification of autocorrelation and cross correlation and its properties. So the aim of this experiment is to find autocorrelation function of the given sequence and verify its properties using the Scilab. So what exactly is the correlation? So correlation is a mathematical technique which indicates whether two signals are related and in the precise quantitative way how much they are related. A measure of a similarity between a pair of energy signal x of n and y of n, for example, if we consider, is given by what the correlation function rxx if it is an autocorrelation, rxy if it is an cross correlation. So for autocorrelation, cross xx of k is equal to summation from n is equal to minus infinity to plus infinity x of n into x of n minus k, where here the k is called lag, indicates the time shift between the pairs. Similarly, if it is an cross correlation, then it is rxy of k, which is equals to summation from n is equal to minus infinity to plus infinity x of n into x y of n minus k, where we are considering the two signals here for the cross correlation. So cross correlation is the function where it defines the correlation of the two different signals, whereas the autocorrelation is of the same signals. So what are the properties of this both cross correlation and autocorrelation? The first property is the periodicity. Periodicity is the condition where this rxx of k naught is equals to rxx of 0. Then the rxx of k is periodic with periods k naught. And the second property is the symmetric. Symmetric means what? Rxx of m is equal to rxx of minus m. So we can say that it is an even function. So next is the mean square value. So the autocorrelation function at k is equal to 0 is equal to mean square value of the process. It means at 0 lag, at L is equal to 0, or here we have considered it as an k, so k is equal to 0. The sample values of autocorrelation or the cross correlation sequences has its maximum value, that is equal to the total energy of the signal, and it is given by rxx of 0 is equal to ex is equals to summation from n is equal to minus infinity to x infinity x square of n, where it is greater than or equal to 0. So these properties have to be executed using an Scilab. So the algorithm is simple. So we have to input the sequences that we are verifying the autocorrelation function and the cross correlation function, and we have to specify the length of the sequence. Then we have to define the input sequences. If it is autocorrelation, a single input is given. If it is a cross correlation, the two inputs are given, and we have to define the autocorrelation function, and in coming for the cross correlation function we have to give the cross correlation functions. So next so this autocorrelation function is executed using an excorr function to get an autocorrelated outputs. So if you have an same signal, so it is simply excorr of x comma x. If you are considering the two different signals x and y, then the command used is excorr of x comma y. Then we have to plot the sequences. So this is what the basic logic behind the autocorrelation and cross correlation functions. So this we have to execute using a Scilab. So open the Scilab. So already the program is typed for autocorrelation function. So see here, the first we have to define the input sequence, then the length, then y is what? The autocorrelation function variable which gives the output of the autocorrelation. So it is given as excorr of x comma x. So x comma x is a single, so it is an autocorrelation function. So we can display the values also, and the range is taken from 0 to n minus 1. So we are going to plot the two different signals here, the input sequence and the autocorrelation function. So the subplot 2 comma 1 comma 1, the first position is for the input sequence, then next is for the autocorrelated function. So here for autocorrelation function, the range specified should be from minus infinity to plus infinity, right? So here the minus infinity means here we are considering the range n, so it is taken as from minus n minus of n minus 1 to plus n minus 1 at the unit of 1. Okay, so this is how we are going to plot it. So once it is typed, so we can execute it, save and execute it, and the graphical window is like this. So the input sequence is this one. So already we have defined here 1 2 3 4, so it is 1 2 3 4. So if you want to know the values here, so you can click on this toggle data tip modes, and on the tip of this one you can click here, so you'll get the values. See, it's not visible there. Yeah, like this we'll get the values. So we have to click it on the tip of the sequence where you want to display this one. Okay, similarly here also, so you can read the values here only. Okay, fine. So this is what the input sequence and the autocorrelation. So here what we are verifying, the first property, so it is an even function. So at x is equal to 0, so the number of sequences are equally distributed, that is x of m is equal to x of minus m, and at at n is equal to 0 you can see the maximum value of 30, and in the console window you can see the values 4 11 20 30. So the maximum is the 30 at n is equal to 0, and you have an equal number of sequences at the left side as well as the right side. So this is the autocorrelation. So similarly we have a program here for cross correlation, where we are defining the two different sequences x and n, and z gives you the correlated output, where the command used here is xcorr x comma y. Okay, the same happens, the same thing we are going to plot it here. So here we are plotting the two different sequences, right? So one is n1 with the x and another is n2 with the y. Here n1 is ranging from 0 to n minus 1, as well as n2 is ranging from 0 to n minus 1, whereas the m for the correlated output, it is from minus of n minus 1 to n minus 1. Okay, and just give the x label, y label, title. So and one more thing I like to note here is that for discrete values the command used is plot 2d3. Okay, so if it is an continuous signal, the command used is just plot, whereas for the discrete values, for the discrete sequences, the command used is plot 2d3. And once you save and execute it, you can see the graph. One is input sequence, second one is second sequence, and finally the cross correlation output. So here also at x is equal to 0, at maximum you will have an maximum energy. Okay, so here where the scale is defined based on this two inputs. So here the maximum, here you have range from 0 to 3, and here it is from 0 to 5, right? So where we can see the maximum, so it is at minus 2, not at the 0. This is very important, and the property is satisfied. So when you look at this console window, so you can see the minus 1 1 5 15 5 1 minus 1. So these are the values what you can see, where you have a maximum value of 15 at where minus 2. Okay, so this is what the cross correlation, and this completes our experiment number 5.